All right, let's solve some exponential equations. What I mean by an exponential equation is any equation where the variable is the power. Right? We're used to seeing things that are like, x to the 7th equals, 100 or something like that. That's not going to be an exponential equation. For an exponential equation, that's more like 7 to the x power is equal to 100. Right? The variable has to be the power. And the type of equation that we're going to deal with is a very specific one, one that's going to utilize this property of equality that if b to the x is equal to b to the y, so the bases of each exponential are the same, but the variables are in the powers, then the two powers have to be equal to each other. So here's a good one. 2 to the x is equal to 8 to the third. All right. Now, these two exponentials do not have the same base yet, but we could rewrite them so that they do have a base of 2. So right now I have 2 to the x on the left, and over here I have 8 to the third. But I want to rewrite that 8 as a power of 2, and 8 is 2 to the third power. Now we'll have the same base on both sides of the equation. So on the left side we'll have 2 to the x, and on the right side our base will be 2, but we have to figure out what the new power is going to be. And since we have a power to a power, that means we multiply them together. 3 times 3 is 9. Now since our bases are the same, their powers are the same, and x is equal to 9. If you wanted to check it, you could do that real quick. Just plug x into the left side, 2 to the 9th power, and you'll get 512. And then also figure out what 8 to the third is, and guess what? It'll also be 512. So let's use that same strategy on a few more examples. Here we have 4 to the 2n minus 1 is equal to 64. All right, 64 is a power of 4. So we could rewrite that as being 4 to the third. Now that our two bases are the same, that means that their two powers have to be equal to each other. So 2n minus 1 is equal to 3. And finish like you normally would. Add 1 to both sides, divide both sides by 2, and we get n is equal to 2. How about 9 to the 2x minus 1 is equal to 3 to the 6x? Now we have the variables on both sides of the equation, but the plan is still the same. Get the bases to be equal to each other. So where we have 9 to the 2x minus 1 is equal to 3 to the 6x, we can rewrite 9 as being 3 squared. Now we'll have the same bases, 3 over here and 3 over here. But our new power on the left, when we go power to a power, we multiply them together. So 2 times the quantity 2x minus 1 is 4x minus 2. Now our bases are the same, so those powers have to be the same. And we solve like normal. Subtract 4x and divide by 2, and we'll get x is equal to negative 1. If you're a little suspicious of that, go ahead and plug it back in to see if we're correct. So if x is negative 1, on the left-hand side we'll have 9 to the 2 times negative 1, which is negative 2, minus 1. So that's 9 to the negative third. The negative puts it in the denominator, and 9 to the third is 729. We do the same thing on the right side of the equation. 3 to the 6x, and if x is negative 1, that'd be 3 to the negative 6. The negative puts it in the denominator, and 3 to the 6th power is 729. So it will be equal to each other. Let's go with one last example. 5 to the 5x is equal to 125 to the x plus 2. And of course our strategy is still the same. Get those bases to be the same. 125 to the x plus 2. That 125 is 5 to the third power. Now we'll have the bases that are equal to each other, so 5 to the 5x. And on the right side, when we go power to a power, 3 times the quantity x plus 2 is 3x plus 6. Now our bases are the same, so the two powers are going to be equal to each other. 5x is equal to 3x plus 6. 2x equals 6. X equals 3. To check that, we can take x equals 3, plug that into each side. If we plug it into the left side, when x is 3, the power will be 15. Plugging that in will give us a huge number on our calculator. But if we look at 125 to the x plus 2, when x is 3, that's 125 to the 5th. 125, like we said, is 5 to the 3rd to the 5th, which again is going to be 5 to the 15th. So these two sides are equal to each other, and there is our solution. Now this is a very specific kind of exponential equation. We are going to learn other methods for solving exponential equations, but right now we're just trying to get both bases to be the same, so then both of their powers would be equal to each other.